Hello, 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 ladies and gentlemen, and welcome back to the 2001 Fermat paper. That's the grade 11 contest put out by the University of Waterloo. We just did question 12 in the last video, so now we're up to question number 13, and let's take a look at that. So question 13 involves this nice cube, A, B, C, D, E, F, G, H, and we've got this extra point P here. So let's read through the question. So A, B, C, D, E, F, G, H is a cube having a side length of 2. P is the midpoint of EF. Okay, so we've got that shown with these little hash marks through the line. The area of triangle APB is, okay, so we've connected P up to A and B, which are the endpoints of sort of the opposite edge from the one that P is on. And we're asked to compute the area of this triangle APB. Well, one thing I noticed is that AB, well, that kind of would serve as a base for this triangle, but getting a height for it, well, that's a different question altogether. But let's draw ourselves a picture. In fact, I think we're going to be drawing a couple pictures here. Alright, so we'll put the triangle we're talking about in green, I guess. So we're talking about A, B, and we've got this point down here, P. So this triangle goes through our cube. Now, if we were to change perspectives, here we're looking at it sort of on I don't know, is this isometric projection? I can never quite remember. But if we look at it just from a top-down view, and we take a look at our green triangle, it looks like this. There's P over here, A, and B. So if we just look at it like this, we might be tempted to drop a perpendicular here. We know our base is going to be 2. We have to ask ourselves, what's the height? Now, if this were a flat triangle, we'd be able to tell that the height is just 2. But it's not a flat triangle, because if we take a look at the altitude that we're talking about, it doesn't lie in on any particular face, so it's not going to have a height of 2. But if we, now having added this altitude in, then rotate and look at a side view, well, we can see A and B are sort of going to line up. And P is going to be down here. The triangle is going to run along this way. And our altitude is going to run along it with the triangle. Because, of course, our altitude lies in the exact same plane as the triangle itself. And this we can work out because we are told that the side lengths are 2. And we have a nice little right angle triangle here. So we have a right angle triangle with legs 2. So that must mean the length is 2 root 2. So the altitude here is going to be 2 root 2. This is just a quick Pythagorean theorem. So now that we have the altitude is 2 root 2, we can add that in, and now it's a simple 1/2 base times height calculation. So our base is AB, so 1/2, 2, and our height, our altitude that we just worked out is 2 root 2. Well, those ones are going to cancel out. We're just going to have 2 root 2 as our final answer. And let's check. 2 root 2 is also known as the square root of 8. So we get an answer of A. Okay. And that concludes question number 13. So we're going to move right on to question number 14, but we'll do that in the next video. So I'll see you guys then.